Here's your next example. Using enthalpies of formation, calculate the change in enthalpy for the thermite reaction. This reaction is used to join railroad rails together, and we do a demonstration of this in our June term course, plug. Because the reaction generates so much energy as heat, the iron produced is initially in the liquid state. The thermite reaction is shown by the following equation. Alright, so the first thing that you should always see is I have an equation. Let's make sure that I balance it. So I'm going to need two. Oh, hey, let's switch back to something. Two aluminums to balance the aluminums, two irons, and then the oxygens are balanced. Okay, good. So, it says using enthalpies of formation. This is a big clue, all right? You're trying to find the enthalpy of this reaction. And in order to do this, you're given some, you know that you need to use the enthalpy of formation of Fe2O3 and Al2O3. Okay? The iron and the aluminum are elements in their standard states. So you're really just using enthalpies of formation of these two compounds and then hoping that everything works out. Okay? So this is why I stress so much that you be able to write these pretty easily, because you're going to need to use them rather a lot. So this is going to be iron plus oxygen gas, and that's going to be 3/2 oxygen gas to get the 3. And if I look at my enthalpy of formation for Fe2O3, it's right down here, 824.8, negative 824.8 kilojoules per mole. And I'm going to do, need to put a 2 there to balance. I'm going to do the same thing with the aluminum. Solid aluminum plus 3/2 O2 again yields Al2O3, and these are solid. Fe2O3 is solid, and Al2O3 is also a solid, and it's negative 1676 kilojoules per mole. Again, these were just lifted from the master document. Okay, this is solid, and now I can figure out what I'm going to need to do to get this stuff to balance. All right. So two aluminum. The Fe2O3, I need to be in the reactant side, which means I'm going to need to flip this. Okay. And the Al2O3 is fine the way it is. So what I'm going to do, I'm not going to rewrite this. I'm just going to flip this right underneath. Okay. And so this is Fe2O3 yields 2Fe plus 3/2 O2. And delta H, remember, if I flip something, I need to change the sign. So this is going to be now positive 824.8 kilojoules per mole. All right, and then I'm just going to draw a single line through this so I don't get confused by it. Okay? And then I'm going to kind of look for stuff to cancel. Okay? Now, I see oxygens on both sides. So that goes away, and that goes away, and nothing else cancels. So I can just kind of create my equation. So this is 2Al solid plus Fe2O3 solid, this is a gas, yields 2Fe solid plus Al2O3 solid, and delta H for this reaction is negative 851.2 kilojoules per mole. Okay, so this is exothermic, which it said in the reaction, this generates a lot of heat. Okay, so that at least gives us an idea that the sign and the magnitude should be large. This is the correct equation from above, so everything should be good.